So in Module 3.1, we introduced the concept of limits and looked at some relatively simple problems. Not to say that it's easy, but we'll start looking at some more complicated examples, different cases, as we continue through this module. So in Module 3.2, I would just start off by suggesting that you keep in mind the idea that what limits are a method for describing the behavior of a function around certain points. So in this module in particular, we're talking about infinite limits and end behavior. We want to start off by just demonstrating what does it look like. So when we say infinite limits, when we say end behavior, what are we talking about? So let's start by considering this function f of x. What we want to know is what's happening to our function as x approaches these different values. So let's start with part A. As x approaches 1, in this case from the left-hand side. So let's add a few labels here, just to make sure our graph is clear. We're assuming that this dashed line is x equals 1. This horizontal dashed line is y equals 1. So as x approaches 1 from the left-hand side, again, we trace along our function, getting closer and closer and closer to this dashed line. We never actually cross that because in this case that's a vertical asymptote. This just keeps decreasing and decreasing and decreasing. So as x approaches 1 from the left-hand side, f is approaching negative infinity. So f is approaching negative infinity. As soon as we identify that our function is headed to negative infinity, positive infinity, we can automatically identify this as a vertical asymptote. So some imaginary line that our function never crosses. Now in part B, we want to look at similarly what happens as x approaches 1 from the right. So as x approaches 1 from the right, again, we're going to trace along the graph. As we get closer and closer to that line x equals 1, we're getting closer and closer and closer to it. We never cross it, and our function just keeps increasing and increasing. So our function is headed to, in this case, positive infinity, or we could just write simply infinity. And anytime our function is headed to positive infinity, negative infinity, again, anytime we have one of those results, we know that we have a vertical asymptote. In part C, now we're interested in what's happening to our function as x approaches negative infinity. So that means as x keeps getting smaller and smaller, negative farther and farther down. So we would trace along this graph as x heads towards negative infinity. And what we would see here is we have another dashed line that we're getting closer and closer and closer to without ever crossing. So as x approaches negative infinity, our function value is getting closer and closer to that line, y equals 1. So our function value is approaching 1. And what we have here is a horizontal asymptote. And then in part D, we're considering just what's happening at the opposite end of the spectrum as x approaches positive infinity. So as x approaches positive infinity, again, we've got our graph that's going to keep getting closer and closer to that line y equals 1 without ever crossing it. So our function is approaching a value of 1. And again, we find that we have another horizontal asymptote. So limits are just formal ways of describing the behavior of functions. Now we have in some cases vertical asymptotes, horizontal asymptotes that we haven't looked at before. So that's what we're adding to our discussion of limits in this module. So when we talk about the idea of infinite limits, that's a little sloppy. When we talk about the idea of infinite limits, What we're concerned with is finding any possible vertical asymptotes. When we talk about end behavior, we're concerned with finding any horizontal asymptotes. Or if there are no horizontal asymptotes, is the end behavior of our function headed off to positive infinity, negative infinity? What's happening at the extreme values for x? So a couple of things to keep in mind. Not all graphs have asymptotes. So they might not exist, they might exist. And the other thing to keep in mind is that end behavior can be different at each end of the graph. So just to look at a couple of examples here that we can very quickly make up. If we looked at the graph of something that looked like x cubed, looks more or less like that. We see as x approaches positive infinity, our function is headed to positive infinity. But as x approaches negative infinity, our function is headed to negative infinity. So in this case, at either end of the graph, f is headed to either positive or negative infinity. We could have a horizontal asymptote at one end of our graph, but at the other end of our graph, our function could be headed to positive infinity, negative infinity. So we can have a horizontal asymptote just on one end of the graph. Or, of course, we might get the exact same end behavior at both ends of the graph. So in this case, with this parabola, as x approaches negative infinity, this function is headed to negative infinity. As x approaches positive infinity, this graph is headed to positive infinity. So not all graphs have asymptotes, and end behavior can change at each of the two ends. So when we consider end behavior, there's actually always going to be two different problems that we have to evaluate.